We're now going to talk about sampling in a bit more detail. So, the first type of sampling I want to consider is what we call random sampling. Now, random sampling is where every member of the population has an equal chance of being selected. A random sample is generally going to be quite representative of the population, as in it's a good representation of what the population as a whole looks like, and it helps to remove bias. Bias, of course, is where your results tend towards a certain way rather than another one, and we'll see some examples in a minute of how bias is reduced by doing random sampling. There are three main methods of random sampling. The first one is what we call simple random sampling. And a simple random sample is one where if you were to take a sample of, say, size 5 out of a population, a simple random sample would guarantee that every possible sample of size 5 had an equal chance of being selected. So let's say there are 10 units in the population. There are quite a number of ways of sampling 5 of them. In a simple random sample, every single one of those ways has an equal chance of being selected. So we say that more formally like this: a simple random sample of size n is one where every possible sample of size n has an equal chance of selection. Now, there are the method for doing simple random sampling goes like this. First of all, you need to take a sampling frame, so something like a list of everybody that you're interested in, and you allocate each person or thing in your list a unique number. So you need to, first of all, create a sampling frame. So remember, that's just your numbered list of everybody in your population that you wish to take the sample from. Now, secondly, what you need to do is to select numbers at random. So let's say you have 10 people in your list. You need to select 5 numbers from 1 to 10 at random. You have 2 ways of doing this. The first one is with a random number generator. So let's say, for instance, you have Excel or some kind of spreadsheet program at your disposal. You can do a function that looks a bit like this. You type in equals int for an integer, rand, and then you give the limits of your random number. So that would give you a random number between 1 and 10. Or you can use your calculator. You have 2 random number generators on your calculator. The first one, they're both above the decimal point. First one, if you press shift and the decimal point, you get random number, and the hashtag means number. That gives you a random number between 0 and 1, which isn't particularly useful when you've got an ordered list. So what you do instead is take the red writing above the decimal point, which says ran int, and you use the alpha key to get that. So ran int, and you want to say what the limits are of your random numbers. Let's imagine we've got 10 people in a list, so we want a random number between 1 and 10. The way you get a comma is shift and the close bracket, 1 to 10. So the first number that comes up is 10, 4, 6, and so on. So this is our random number generator on the calculator. And once you've selected your sample of 5 units, you're there. Now, the other way of doing it is what we call lottery sampling. This is the idea of picking names out of a hat. So you would write everybody's number onto a ticket, put it into some kind of hat or box or something, shake it around, mix it up, and draw out the required amount. So let's have a look at example 2. We have 100 members of a yacht club, and the owner of the yacht club has an alphabetical list of all of the members, and they want to select a sample of 12 members to fill out a questionnaire. So how could they do this? Well, first of all, they could do via a random number generator. They could number everybody alphabetically from 1 to 100, and then use the function on the calculator or some other random number generator to generate 12 numbers. If the random number generator came up with the same number twice, you'd just keep going until you'd got 12 distinct numbers. And then you would go back to your sampling frame, your list, and you would select the numbers that came out. The other way, of course, is a lottery sample. So you could put numbers 1 to 100 on pieces of paper or tickets, put them into a hat, shake it up and draw out 12 numbers. And there you've got the sample that are going to fill in your questionnaire. Now, this is a particularly good way to avoid bias. Because, let's say for instance, you wanted your members to answer this questionnaire and you stood outside the entrance to the yacht club and you handed out the questionnaire to the first 12 people that came in at the start of a morning on, let's say, a Sunday morning. There's going to be some bias there because there are going to be certain types of people who are able to attend on a Sunday morning and certain types of people who aren't able to attend on a Sunday morning. And that automatically is going to put bias into your sample. So by doing simple random sampling, you're avoiding that bias. The second method of random sampling is called systematic sampling. Now this is where the required elements or people that you want to choose are chosen at regular intervals from an ordered list. So again, you need a sampling frame, you need your ordered list of 100 members of the yacht club. But what you do is this, you pick your first item at random using a random number generator. So let's say person 11 is chosen first. You then select the other people or numbers that you need at regular intervals from that starting number 11. And of course you calculate those regular intervals depending on how many people you need overall. So if you have 100 people on your sampling frame and you want to take a sample of 10, your random number generator starts you from number 11, you would pick number 11, 21, 31 and so on. All the way back round to 91 and then back to number 1 as well. The third type of random sampling is called stratified sampling. And this one's a little bit more detailed and it's particularly useful because it helps us to consider the sizes of subgroups in the population. So what happens is you take your population and you divide it into mutually exclusive layers. Mutually exclusive just means that those layers don't overlap. So for instance, let's stick with the yacht club. You might divide your members into male and female. Now, these layers are called strata. And the singular of that is stratum. You've probably met the word strata before in geography or science when you're talking about layers of rocks underneath the earth. So what you do then is once you've decided how big your strata are, you make sure that your random sample reflects the whole population. So what you need is that the proportion of members in your sample, in each stratum of your sample, is the same as the proportion of members in the whole population. So to put that in more simple terms, if you had 2/3 of your population male and 1/3 female, you would need 2/3 of your sample to be male and 1/3 of your sample to be female. So that's what this formula tells us here. The method for stratified sampling is to first of all calculate the size of each stratum in your sample. So you work out the proportion that are in that stratum in the whole population and you find that proportion of your sample size. You then, once you know how many people you need in each stratum in your sample, you select the members of the sample using simple random sampling, the first type that we discussed. So this is best illustrated with example 3. Example 3 talks about workers in a factory, and the factory manager wants to find out what the workers think of the canteen facilities. So the manager wants to give a questionnaire to a sample of 80 workers. And the manager thinks that different workers in different age groups will have different opinions. So they want this sample to represent the age groups of the population of workers in the factory. So they're going to use a stratified sample to do this. And the way they're going to use a stratified sample is this. First of all, we need to know how big the population is. So we're told in the question that we have got 75 workers in this age bracket, 140 in the next age bracket, and 85 in the last age bracket. So that gives us a total of 300 workers. So we've got 300 factory workers. Now let's work out what proportion of each of these what proportion of the workers is in each age bracket. So 75/300ths are between 18 and 32. That's a quarter. 140/300ths are between 33 and 47. So that's 7/15ths. And 85/300ths are between 48 and 62. That's 17/60ths of the population. I didn't need to simplify these fractions at all. It just helps us to conceptualise what's going on a little easier. So we need a sample of size 80, as the question asks us. So in the 18 to 32 age group, we are going to work out 75/300ths of 80. That was a quarter, so that's going to be 20 workers in that stratum. Now in the 33 to 47 age group, we need 140/300ths of 80. My mental arithmetic doesn't extend to that, so let's work that one out. It's not a whole number, so 37 1/3, so let's round that to approximately 37 workers. Now I'm expecting the next one will probably round up. Let's see. In the 48 to 62 age bracket, we've got 85/300, that proportion of 80. This is not going to be an integer again, so that gives us, 22 2/3, so approximately 23 workers. And you can see that that adds up to 60, 80. So that adds up to our sample size. So that's exactly what we need for each of the strata. So all that happens next is the factory manager gets a sampling frame with all of the 75 workers aged from 18 to 32, numbers them 1 to 75, and uses simple random sampling, either by a lottery sampling or by a random number generator to select 20 of them. Does the same to select 37 of these workers, and the same to select 23 of these workers. Now, each of these three methods of random sampling has its advantages and its disadvantages. So let's go back to simple random sampling first. The advantages, we've already mentioned one of them. We've said that it's free of bias. Everybody's got a completely equal chance of being selected, completely free of bias. It's very easy to implement. Easy is also wrapped up in real terms with the word cheap to implement, especially if your population is small. And if your sample is small. Every single sampling unit is known. So remember, the sampling units are the members of the population. So you have a sampling frame, you have a list, which means you know every single one of them. So you have information about everybody. So each sampling unit is known. You've not missed anybody out, and has equal chance of selection. But there are some disadvantages to it. If your population size or the sample size is large, then this can be really time consuming, potentially expensive. So let's say not easy. Let's think about time and cost for large populations and large samples. And the fact that you need a sampling frame, although it's good because you know every member, it's also in itself time consuming and takes up some effort. So it can be a disadvantage, the fact that you need a sampling frame. Let's look at systematic sampling then and think about the advantages and disadvantages of that one. So it's very, very simple and quick to use. Systematic sampling. Remember, this is the one where you select people at regular intervals from a list. So generally, if we're talking small sizes, you're just going this one and then this one and then jumping to the next one. So systematic sampling is simple and quick. And it's also very simple and quick when you've got large samples and populations. But you've also got the disadvantage that you need the sampling frame. And if your sampling frame isn't random, you've got some potential bias. So bias if this sampling frame is not random. Imagine you put, let's think about our factory workers. If you put all of the 75 younger workers together at the start, let's say you arrange them all in age order, and then your next 140, as you go at regular intervals, you're going to get more of these, but not more that it represents the proportion exactly. So there's potentially going to be some bias there. Now, stratified sampling then. The advantages of stratified sampling are that it reflects the population structure. And that's because of this idea of proportions, and the proportion in the population is represented by the portion in the sample. So it reflects the population structure. It guarantees proportional representation. Ooh, can't spell. Guarantees, that's an A, proportional representation. So that's important. If you have more women than men in your group, we know that they are going to have different thoughts and feelings potentially about certain things. Now, obviously, I'm making very sweeping generalisations here, so please do bear with me with that, and I'm quite aware of what I'm saying. But you might think that women as a group are more likely to prefer certain things to men as a group. Forgive the generalisations. But what that means is if you have a proportional representation, then you know that if your group is predominantly women, then your sample is going to be predominantly women, or vice versa. Now, disadvantages, you do have to spend some time classifying your population into the strata, so that can be time consuming. So classification into the strata is not easy, and remember, by easy I'm kind of referring to things like time and cost here, as well as literally the difficulty of doing it. And then of course we have the fact that when you are choosing from each strata, you bring in the same disadvantages that you had with simple random sampling, because you're then applying simple random sampling. So if you remember, the disadvantages from simple random sampling were the fact that there is a time and cost for working with large populations and samples, and you need the sampling frame. So it's got the same disadvantages of simple random sampling. So you have to bear all of that in mind when you're choosing what type of sampling method to use. Now, I think we've gone through enough for you to be able to have a good go at exercise 1B now. So off you go.